Now we're going to look at exponential applications. We've got compound interest and continuous compounding. Now with compound interest, I have this formula where A is the future amount, P is the present value, that's the amount of money that's invested or borrowed, R is the interest rate. It'll be given as a percent, but you've got to change it to a decimal. N is the number of compounding periods in a year. And your choices there is compounded annually, N would be 1. Compounded semi-annually, N would be 2. Compounded quarterly, N would be 4. Compounded monthly, N would be 12. Compounded daily, N would be 365. So it's how many compounding periods in a year. And T is number of years. The other one is the continuous compounding. I sometimes call this the PERT formula because there's a shampoo called PERT. It's just one way that you can remember it. But A and the P, those are the same variables as are the R and T that we heard earlier. R again has got to be, it'll be given as a percent, but you got to change it to decimal. Now E, my base here, is this number. And it is continuous. It does not end. E is the base amount of growth that's shared by all continually growing processes. It shows up whenever systems grow exponentially and continuously, such as population, radioactive decay, interest calculations, and there's others. But all E is, it represents the idea that all continually growing systems are scaled versions of a common rate. But now the only time I can use this if I see this word, continuous. That's the only time. So now in these problems that I've got down here, we've got to use the correct compound interest formula to determine the final amount. So $2,000 at 8.7% compounded continuously for 8 years. So the correct formula to use would be this one. Now this is my investment, or the amount borrowed. But because of the word continuous, I use this formula. So the 2,000 would go in for P times E. My R would be 0.087 times 8. Move it down a little bit more. Now this whole thing can be done by calculator, so we need to look at that. And the key that I need you to see is this one right here. Do you see the E to the X? Since it's in blue on my calculator, to access it I have to hit second LN, but I'm going to type in this whole thing. So I've got 2,000 second LN. Notice when I do that I have my caret symbol and also the parentheses. Now if you have the new operating system, you'll just have the little baby exponent up there. So let me type in 0.087 times 8. I've got to close my parentheses. Let me hit enter. So now in this problem, 2,000, if we had $2,000 to invest at 8.7% compounded continuously for 8 years, it would over double. So my answer would be $4,011.43. Now this is money, so we round to the hundreds. Let's look at this one. $950 at 3% compounded monthly for 20 years. So first thing you need to notice is I don't see a continuous. That means this formula. Monthly, that means my end value is 12. So let's get my formula here. Let me pull it down. So the P would be 950. The interest, or my interest rate, my R is 0.03. Be careful. You take your decimal 2 places to the left and drop the percent sign. N is 12, so I'm going to have 12 here. And T is time, which is 20. So let me pull it down a little bit more. Don't want you to see the answer. So this is where I need to put the appropriate values. This whole thing can be done via a calculator. Let me type in 950. I need a parentheses, 1 plus 0.03 divided by 12. I do not need a parentheses around this because your calculator understands order of operations. Now, my exponent, this is where you have to be careful. If you don't multiply it out, you have to have parentheses. 12 times 20. So you might try it this way and then also try the same problem but raise it to the 240 and see if you come up with the same answer. So $950 would grow over 20 years at that interest rate, compounded monthly, to $1,729.72. There it is. This one, I've got 1,250 at 4.75% compounded semi-annually for 10 years. Semi-annually, n would be 2. So now the formula I need is this compound amount formula, since it does not have the word continuous. So 1,250 goes here. My R would be 0.0475. N would be 2. And my time would be 10. So try putting this in your calculator. This time I'm going to multiply that, so I don't have to use another parentheses. So 1,250 parentheses 1 plus 0.0475 divide by 2, raise it to the 20th. It would grow to almost $2,000. The banks are not going to give you $2,000. They're going to give you $1,998.89. Pennies add up. This one, compounded quarterly. N would be 4. The formula, same formula I had here, because I do not see the word continuous. So my money goes at P for present value. R would be 0.035, be careful. My N, both of them would be 4, and the T would be 17. So 4122 parentheses 1 plus 0.035 divide by 4 raised to the, that would be, 68? Try 4 times 17 in parentheses. So let's see if I multiplied right. Yay! Now, this is money. We round to the second decimal place. So since this is 5 or greater, I add 1, which changes everything. So $7,454 is what we would have if under that situation. So $3,150 at 2.5% compounded continuously for 14 years. So I have to use my continuous compounding formula. So $3,150 would be here times E, interest rate 0.025 times 14. Okay, so 3,150. Second ln, because I want the E raised to the 0.025 times 14. So $4,470.06. What was the interest earned in problem number 4? Problem number 4 is right here. Now guys, interest earned, that's when you take what your money grew to minus the original principal. Interest is the compound amount formula minus your original principal. So I would have 7,454 minus 4,122. So the interest earned on that problem would be $3,332. So that's it for this section. Thank you.